So this is our section starting chapter 6, 6.1, adding and subtracting polynomials. So first we have to talk a little bit about what a polynomial is. We're going to start by the definition with a monomial. A monomial meaning one term. And terms are in this form where A is a real number and M is positive integer. Now we can have other types of integers, but for our polynomial work, our exponents will be positive integers. That's what a monomial is. Notice that it's in terms of multiplication. A is a number, a real number, and x is the variable here. So that's what a monomial is. A binomial is when we have two terms in the form, two monomials added or subtracted together. And a trinomial is when we have three terms. So bi for two terms and tri for three terms. And remember, terms are separated by addition and subtraction signs. Poly, meaning many terms. Now, all of them are polynomials. A monomial, binomial, trinomial, they're all polynomials. But sometimes we like to specifically talk about polynomials that have one term or two terms or three terms. A constant is something that stays constant, like the number 5. That would be considered a constant. It can be a term in a polynomial, but it doesn't have a variable attached to it. And a coefficient, the coefficient is going to be A in our monomials. It's going to be the number in front of the variable. Okay, so now we're going to work a little bit with these terms. So the first thing they want us to do is tell whether it's a polynomial, a binomial, a polynomial, a monomial, a binomial, or a trinomial. So we're going to look at this expression right here. By the way, these are all expressions, not equations. 5b. So that's going to be a monomial because it's just one term. 5 is a constant, but it's 5b. So, 5 is the coefficient for that term. Okay, the next one, notice that there are 1, 2, 3, 4 terms. Remember, terms are separated by addition and subtraction signs. So this would be considered a polynomial because it's got so many terms. Can't really call it a binomial or a trinomial or a monomial because it has too many terms. Now, if we look at this first term, we could say the coefficient on that term is 8. The second term has a coefficient -7. The third term has a coefficient of -1. And the last term is our constant here, which is -3. Now, it's very important that you look in front of the coefficient or the constant to decide whether it's positive or negative. All right, let's go to the next one. And this next one would be a trinomial because it has 3 terms. And I like to talk about the coefficients because we're going to work with those a lot. So we have a coefficient here of -3, coefficient here of -5, and the constant here is 9. All right, our next term over here is a binomial because it has 2 terms. Keep spelling binomial. 81 and -4a squared. So here's your constant this time, 81, and then the coefficient on a squared is -4. Our last term here is a monomial. It's just one term. The coefficient is -5 and the exponent is 6. That's just one term. Now we're going to talk about the degree of a polynomial. The degree of a polynomial is the highest degree of any one term. So if I look at this first term, this was a polynomial we had before, the degree on that is 2. It's the exponent. The degree here, you have to think of x as having an exponent of 1, so the degree is 1. And the degree on a constant is 0. So what's the highest degree? 2. So this would be, the degree here would be 2. Or they might say second degree polynomial. but the degree is 2. Now, that's not too bad. You could look through a polynomial in one variable and find those degrees, find the highest one. That's not too bad. It's a little bit different when we have a polynomial in more than one variable. Now, this doesn't come up a lot, but I want to go over it. So our first term here, you see m to the 4th. And why I say it's in more than one variable, you have some terms with m and some terms that have both m and n. So that makes it a degree in 2 variables because you have a variable of m and a variable of n. So we look at the degree of the first term. That's 4. That probably makes sense to you because of what we did before. So it's just the exponent on m. But what do you say for the degree of this term? Well, what you have to do when there's 2 variables is you have to add those exponents. So the degree for that term is 5 because 3 plus 2. And then what are you going to say the degree is for this last term? Well, you have to consider m has an exponent of 1. So the degree for the last term is going to be 6 because of the 1 plus 5. So when you do that, the degree of this polynomial, degree, is 6 because it's the highest degree for any one term. Okay, we went over that. Standard form for a polynomial, we put the exponents from largest to smallest. So a while ago we had 81 minus 4a squared. That would not be considered in standard form, but we could rewrite it as negative 4a squared plus 81. And now it's in standard form. So you want the highest exponent first, and then you want them to go in descending order. Sometimes I'll just give them to you that way. Sometimes you have to rewrite them, put them in standard form. Now, when there's more than one variable, well, if we get to that, we'll talk about that. Okay, so let's look at the degrees of these polynomials. So they're all polynomials here. The degree here is going to be 1. Because you just have an exponent of 1 on that b, and it's a monomial, it's the only term. The degree here, it's in one variable, it's in the variable z, so we want the highest exponent, which is 4. And by the way, that's in standard form. The next one is in 2 variables, so it's a little bit trickier. The degree of this term is 9. We're going to add those exponents. The degree of this term is 12, and the degree of the constant is 0. So you figure out what the degree is for each term individually, and then we're going to take the highest one for the degree of the polynomial. So 12 for that one. This next problem is also in 2 variables. So the first one has a degree of 3, and the next one has a degree of 1. The degree for this polynomial then would be 3. And our last one here, it's a constant, so it has a degree of 0. It's just a constant. It's not a very exciting polynomial. And you might say, well, it's just a -9, but it is considered a polynomial. All right, so I think that finishes off page 1. So we'll go to page 2. Oops, I'm way at the bottom. All right, and we continue. Now we want to get into how we're going to add and subtract them. First, we're going to start with monomials. So it's just one term. And what we do is we combine like terms. Now, in order for them to be like terms, you have to have the same variable and the same exponent on that variable. So it's like you're counting up, in this case, q squareds. How many do you have? Here you have 12. Here you have 9. So you have a total of 21. This would be equal to 21q squared. All right, the next one, 8m, you're going to want to change that to plus 5m. You might remember taking the 2 subtraction signs and making that giant addition sign. That's going to make it 13m. You're counting up how many m's you have. So we're simplifying these expressions when we add and subtract, and that's how those two go. Like terms must have the same variables with the same exponents. And a lot of times when they give you these problems, they're going to use the word simplify. So they want you to simplify the expressions. We're not solving anything, we're just combining what we can combine. So now we have a trinomial here. We have three terms. We have 8y squared, 3z squared, and then minus 3y squared. So which ones can we combine? The y squareds. So we're going to write this as 5y squared plus 3z squared. And then we're done. The next one, well, do we have any like terms? Oop, this one's done. And why is that? Well, this term is m squared n squared. This is an m squared, and this is an n squared. So there aren't any that are exactly like. The only thing that can be different is the coefficients. Then you can combine those terms. But that one's done. That one might seem a little odd. So we have some more polynomials to add and subtract. They put the parentheses to indicate the polynomials. So in this case, you could drop the parentheses. They're not necessary in this case because it's addition. So we're just adding these terms. You can stack them if you want to do it that way. That works too. But we're looking for like terms. So you have a 7x squared and a 1x squared. That's 8x squared. You have a negative 4x and a negative 7x. That's negative 11x. And then finally you have a 5 and a 3, and that's going to be 8. And so we've simplified this polynomial. We've added the two polynomials together. Now we have, in this next one, it's a subtraction problem. We have 8x squared plus 3x minus 19. And now the parentheses matter to us. So we want to make that minus 7x squared plus, because you have minus a minus, you have to distribute that subtraction sign, plus 14. Okay, now what can we combine? Well, 8x squared minus 7x squared, that's 1x squared. You can put the 1, but it's not necessary. I have a 3x. There are no other x terms, so I'm just going to write the 3x. And then the minus 19 and the plus 14, that's going to be minus 5. And then that one's done. This next one has a little bit different situation with the wording. It says subtract this polynomial from this other polynomial. So what you want to do is you want to write 7z squared plus 6z minus 4, that polynomial. You want to write that one first. And this is the one you're subtracting, the 5z squared minus 6z minus 2. So you want to make sure you get them in the right order. Now we can write it without the parentheses, 7z squared plus 6z minus 4 minus 5z squared plus 6z, because I have to distribute that subtraction sign, and then finally it's going to be plus 2. Now I look for the like terms to combine. I get 2z squared, so that's the 7z squared and the minus 5z squared. Then I have 6z and 6z, that's going to be 12z. And then minus 4 and plus 2 is going to be minus 2. And then that's going to be all I have a time for on this video, and so I'll have to pick up the others. We're almost done on the next video. Thank you.